Chapter 11 of How We Think. This LibriVox recording is in the public domain. Chapter 11 Empirical and Scientific Thinking. 1. Empirical Thinking. Empirical thinking depends on past habits. Apart from the development of scientific method, inferences depend upon habits that have been built up under the influence of a number of particular experiences not themselves arranged for logical purposes. A says, "It will probably rain tomorrow." B asks, "Why do you think so?" And A replies, "Because the sky was lowering at sunset." When B asks, "What has that to do with it?" A responds, "I do not know, but it generally does rain after such a sunset." He does not perceive any connection between the appearance of the sky and coming rain. He is not aware of any continuity in the facts themselves, any law or principle, as we usually say. He simply, from frequently recurring conjunctions of the events, has associated them so that when he sees one he thinks of the other. One suggests the other, or is associated with it. A man may believe it will rain tomorrow because he has consulted the barometer, but if he has no conception how the height of the mercury column or the position of an index moved by its rise and fall is connected with variations of atmospheric pressure, and how these in turn are connected with the amount of moisture in the air, his belief in the likelihood of rain is purely empirical. When men lived in the open and got their living by hunting, fishing, or pasturing flocks, the detection of the signs and indications of weather changes was a matter of great importance. A body of proverbs and maxims, forming an extensive section of traditionary folklore, was developed. But as long as there was no understanding why or how certain events were signs, as long as foresight and weather shrewdness rested simply upon repeated conjunction among facts, beliefs about the weather were thoroughly empirical. It is fairly adequate in some matters. In similar fashion, learned men in the Orient learned to predict, with considerable accuracy, the recurrent positions of the planets, the sun, and the moon, and to foretell the time of eclipses, without understanding in any degree the laws of the movements of heavenly bodies; that is, without having a notion of the continuities existing among the facts themselves. They had learned from repeated observations that things happened in about such and such a fashion. Till a comparatively recent time, the truths of medicine were mainly in the same condition. Experience had shown that, upon the whole, as a rule, generally or usually speaking, certain results followed certain remedies, when symptoms were given. Our beliefs about human nature in individuals, psychology, and in masses, sociology, are still very largely of a purely empirical sort. Even the science of geometry, now frequently reckoned a typical rational science, began among the Egyptians as an accumulation of recorded observations about methods of approximate mensuration of land surfaces, and only gradually assumed, among the Greeks, scientific form. The disadvantages of purely empirical thinking are obvious, but it is very apt to lead to false beliefs. 1. While many empirical conclusions are, roughly speaking, correct, while they are exact enough to be of great help in practical life, while the presages of a weather-wise sailor or hunter may be more accurate, within a certain restricted range, than those of a scientist who relies wholly upon scientific observations and tests, while indeed, Empirical observations and records furnish the raw or crude material of scientific knowledge, yet the empirical method affords no way of discriminating between right and wrong conclusions. Hence it is responsible for a multitude of false beliefs. The technical designation for one of the commonest fallacies is post hoc, ergo propter hoc, the belief that because one thing comes after another, it comes because of the other. Now, this fallacy of method is the animating principle of empirical conclusions, even when correct, the correctness being almost as much a matter of good luck as of method. That potatoes should be planted only during the crescent moon, that near the sea people are born at high tide and die at low tide, that a comet is an omen of danger, that bad luck follows the cracking of a mirror, that a patent medicine cures a disease, these and a thousand like notions are asseverated on the basis of empirical coincidence and conjunction. Moreover, habits of expectation and belief are formed otherwise than by a number of repeated similar cases, and does not enable us to cope with the novel. 2. The more numerous the experienced instances, and the closer the watch kept upon them, the greater is the trustworthiness of constant conjunction as evidence of connection among the things themselves. Many of our most important beliefs still have only this sort of warrant. No one can yet tell with certainty the necessary cause of old age or of death, which are empirically the most certain of all expectations. But even the most reliable beliefs of this type fail when they confront the novel. Since they rest upon the past uniformities, they are useless when further experience departs in any considerable measure from ancient incident and wonted precedent. Empirical inference follows the grooves and ruts that custom wears, and has no track to follow when the groove disappears. So important is this aspect of the matter that Clifford found the difference between ordinary skill and scientific thought right here. Skill enables a man to deal with the same circumstances that he has met before. Scientific thought enables him to deal with different circumstances that he has never met before. And he goes so far to define scientific thinking as the application of old experience to new circumstances, and leads to laziness and presumption. 3. We have not yet made the acquaintance of the most harmful feature of the empirical method. Mental inertia, laziness, unjustifiable conservatism are its probable accompaniments. Its general effect upon mental attitude is more serious than even the specific wrong conclusions in which it has landed. Wherever the chief dependence in forming inferences is upon the conjunctions observed in past experiences, failures to agree with the usual order are slurred over, cases of successful confirmation are exaggerated. Since the mind naturally demands some principle of continuity, some connecting link between separate facts and causes, forces are arbitrarily invented for that purpose. Fantastic and mythological explanations are resorted to in order to supply missing links. The pump brings water because nature abhors a vacuum. Opium makes men sleep because it has a dormitive potency. We recollect a past event because we have a faculty of memory. In the history of the progress of human knowledge, out-and-out myth accompany the first stage of empiricism, while hidden essences and occult forces mark its second stage. By their very nature, these causes escape observation, so that their explanatory value can be neither confirmed nor refuted by further observation or experience. Hence belief in them becomes purely traditionary. They give rise to doctrines which, inculcated and handed down, become dogmas. Subsequent inquiry and reflection are actually stifled. And to dogmatism. Certain men or classes of men come to be the accepted guardians and transmitters, instructors of established doctrines. To question the beliefs is to question their authority. To accept the beliefs is evidence of loyalty to the powers that be, a proof of good citizenship. Passivity, docility, acquiescence come to be primal intellectual virtues. Facts and events presenting novel and variety are slighted, or are sheared down till they fit into the Procrustean bed of habitual belief. Inquiry and doubt are silenced by citation of ancient laws or a multitude of miscellaneous and unsifted cases. This attitude of mind generates dislike of change, and the resulting aversion to novelty is fatal to progress. What will not fit into the established canons is outlawed. Men who make new discoveries are objects of suspicion and even of persecution. Beliefs that perhaps originally were the products of fairly extensive and careful observation are stereotyped into fixed traditions, and semi-sacred dogmas are accepted simply upon authority, and are mixed with fantastic conceptions that happen to have won the acceptance of authorities. 2. Scientific method. Scientific thinking analyzes the present case. In contrast with the empirical method stands the scientific. Scientific method replaces the repeated conjunction or coincidence of separate facts by discovery of a single comprehensive fact, effecting this replacement by breaking up the coarse or gross facts of observation into a number of minuter processes not directly accessible to perception. Illustration from suction of empirical method. If a layman were asked why water rises from the cistern when an ordinary pump is worked, he would doubtless answer by suction. Suction is regarded as a force like heat or pressure. If such a person is confronted by the fact that water rises with a suction pump only about 33 feet, he easily disposes of the difficulty on the ground that all forces vary in their intensities and finally reach a limit at which they cease to operate. The variation with elevation above the sea level of the height to which the water can be pumped is either unnoticed, or if noticed, is dismissed as one of the curious anomalies in which nature abounds. Of scientific method relies on differences. Now, the scientist advances by assuming that what seems to observation to be a single total fact is in truth complex. He attempts, therefore, to break up the single fact of water rising in the pipe into a number of lesser facts. His method of proceeding is by varying conditions one by one, so far as possible, and noting just what happens when a given condition is eliminated. There are two methods for varying conditions. The first is an extension of the empirical method of observation. It consists in comparing very carefully the result of a great number of observations which have occurred under accidentally different conditions. The difference in the rise of the water at different heights above the sea level, and its total cessation when the distance to be lifted is, even at sea level, more than 33 feet, are emphasized instead of being slurred over. The purpose is to find out what special conditions are present when the effect occurs and absent when it fails to occur. These special conditions are then substituted for the gross fact, or regarded as its principle, the key to understanding it. and creates differences. The method of analysis by comparing cases is, however, badly handicapped. It can do nothing until it is presented with a certain number of diversified cases. And even when different cases are at hand, it will be questionable whether they vary in just these respects in which it is important that they should vary in order to throw light upon the question at issue. The method is passive and dependent upon external accidents. Hence the superiority of the active or experimental method. Even a small number of observations may suggest an explanation, a hypothesis or theory. Working upon this suggestion, the scientist may then intentionally vary conditions and note what happens. If the empirical observations have suggested to him the possibility of a connection between air pressure on the water and the rising of the water in the tube where air pressure is absent, he deliberately empties the air out of the vessel in which the water is contained and notes that suction no longer works. Or he intentionally increases atmospheric pressure on the water and notes the result. He institutes experiments to calculate the weight of air at the sea level and at various levels above, and compares the results of reasoning based upon the pressure of air of these various weights upon a certain volume of water with the results actually obtained by observation. Observations formed by variation of conditions on the basis of some idea or theory constitute experiment. Experiment is the chief resource in scientific reasoning because it facilitates the picking out of significant elements in a gross, vague whole. Analysis and synthesis again. Experimental thinking, or scientific reasoning, is thus a conjoint process of analysis and synthesis, or, in less technical language, of discrimination and assimilation or identification. The gross fact of water rising when the suction valve is worked is resolved or discriminated into a number of independent variables, some of which had never before been observed or even thought of in connection with the fact. One of these facts, the weight of the atmosphere, is then selectively seized upon as the key to the entire phenomenon. This disentangling constitutes analysis. But atmosphere and its pressure or weight is a fact not confined to this single instance. It is a fact familiar, or at least discoverable as operative in a great number of other events. In fixing upon this imperceptible and minute fact as the essence or key to the elevation of water by the pump fact has thus been assimilated to a whole group of ordinary facts from which it was previously isolated. This assimilation constitutes synthesis. Moreover, the fact of atmospheric pressure is itself a case of one of the commonest of all facts, weight or gravitational force. Conclusions that apply to the common fact of weight are thus transferable to the consideration and interpretation of the relatively rare and exceptional case of the suction of water. The suction pump is seen to be a case of the same kind or sort as the siphon, the barometer, the rising of the balloon, and a multitude of other things which at first sight it has no connection at all. This is another instance of the synthetic or assimilative phase of scientific thinking. If we revert to the advantages of scientific over empirical thinking, we find that we now have the clue to them. Lessened liability to error. A. The increased security, the added factor of certainty or proof, is due to the substitution of the detailed and specific fact of atmospheric pressure for the gross and total and relatively miscellaneous fact of suction. The latter is complex, and its complexity is due to many unknown and unspecified factors. Hence, any statement about it is more or less random, and likely to be defeated by any unforeseen variation of circumstances. Comparatively, at least, the minute and detailed fact of air pressure is a measurable and definite fact, one that can be picked out and managed with assurance. Ability to manage the new. B. As analysis accounts for the added certainty, so synthesis accounts for ability to cope with the novel and variable. Weight is a much commoner fact than atmospheric weight, and this in turn is a much commoner fact than the workings of the suction pump. To be able to substitute the common and frequent fact for that which is relatively rare and peculiar is to reduce the seemingly novel and exceptional to cases of a general and familiar principle, and thus to bring them under control for interpretation and prediction. As Professor James says, think of heat as motion, and whatever is true of motion will be true of heat. But we have 100 experiences of motion for every one of heat. Think of rays passing through this lens as cases of bending toward the perpendicular, and you substitute for the comparatively unfamiliar lens the very familiar notion of a particular change in direction of a line, of which notion every day brings us countless examples. Interest in the future or in progress. C. The change of attitude from conservative reliance upon the past, upon routine and custom, to faith in progress through the intelligent regulation of existing conditions, is, of course, the reflex of the scientific method of experimentation. The empirical method inevitably magnifies the influences of the past. The experimental method throws into relief the possibilities of the future. The empirical method says, wait till there is a sufficient number of cases. The experimental method says, produce the cases. The former depends upon nature's accidentally happening to present us with certain conjunctions of circumstances. The latter deliberately and intentionally endeavors to bring about the conjunction. By this method, the notion of progress secures scientific warrant. Physical versus logical force. Ordinary experience is controlled largely by the direct strength and intensity of various occurrences. What is bright, sudden, loud, secures notice, and is given a conspicuous rating. What is dim, feeble, and continuous gets ignored, or is regarded as of slight importance. Customary experience tends to the control of thinking by considerations of direct and immediate strength rather than by those of importance in the long run. Animals without the power of forecast and planning must, upon the whole, respond to the stimuli that are most urgent at the moment, or cease to exist. These stimuli lose nothing of their direct urgency and clamorous intensity when the thinking power develops. And yet thinking demands the subordination of the immediate stimulus to the remote and distant. The feeble and the minute may be of much greater importance than the glaring and the big. The latter may be signs of a force that is already exhausting itself. The former may indicate the beginnings of a process in which the whole fortune of the individual is involved. The prime necessity for scientific thought is that the thinker be freed from the tyranny of sense stimuli and habit, and this emancipation is also the necessary condition of progress. Illustration from moving water. Consider the following quotation. When it first occurred to a reflecting mind that moving water had a property identical with human or brute force, namely,
the property of setting other masses in motion, overcoming inertia and resistance. When the sight of the stream suggested through this point of likeness the power of the animal, a new addition was made to the class of prime movers, and when circumstances permitted, this power could become a substitute for the others. It may seem to be the modern understanding, familiar with water wheels and drifting rafts, that the similarity here was an extremely obvious one. But if we put ourselves back into an early state of mind, when running water affected the mind by its brilliancy, its roar and irregular devastation, we may easily suppose that to identify this with animal muscular energy was by no means an obvious effort. Value of abstraction. If we add to these obvious sensory features the various social customs and expectations which fix the attitude of the individual, the evil of the subjection of free and fertile suggestion to empirical considerations becomes clear. A certain power of abstraction, of deliberate turning away from the habitual responses to a situation, was required before men could be emancipated to follow up suggestions that in the end are fruitful. Experience as inclusive of thought. In short, the term experience may be interpreted either with reference to the empirical or to the experimental attitude of mind. Experience is not a rigid and closed thing. It is vital and hence growing. When dominated by the past, by custom and routine, it is often opposed to the reasonable, the thoughtful. But experience also includes the reflection that sets us free from the limiting influence of sense, appetite, and tradition. Experience may welcome and assimilate all that the most exact and penetrating thought discovers. Indeed, the business of education might be defined as just such an emancipation and enlargement of experience. Education takes the individual while he is relatively plastic, before he has become so indurated by isolated experiences as to be rendered hopelessly empirical in his habit of mind. The attitude of childhood is naive, wondering, experimental. The world of man and nature is new. Right methods of education preserve and perfect this attitude, and thereby short circuit for the individual the slow progress of the race, eliminating the waste that comes from inert routine. End of chapter 11.